Bismillahirrahmanirrahim. Subhanaka la ilma lana illa ma 'allamtana innaka antal alimul hakim. Dear students, assalamu alaikum. Today we will discuss DQ. Okay, so what is a DQ? This is a data structure and how its working mechanism and its daily life example and the possible operations on a queue. Okay, and what are the types of queue? So let's start. Queue is a logical data structure. Logical means you can arrange the elements of the queue within the RAM. Okay, so this is called the logical data structure inside of the primary memory or physical memory. So this is the logical data structures, arrangement of elements within the physical memory. This is called the logical data structure. And queue is a static data structures. When you implement queue by using array data structure, so you cannot change the size of the queue. This is called the static data structure. And queue is a linear data structure. There is one preceding and one succeeding and preceding elements from a specific element. Okay, so their data structure is called queue data structure. Queue is a logical, static and linear data structure. Two operations are possible. One is called the insertion operation or push operation or pushing, or this can be also called is in queuing. Okay, and the other operation that is possible on the queue is deletion operation or pop operation or popping or dequeuing operation. There are two sides of the queue. One is called the front end and another side of the queue is called the rear end. In stack there was only one side from which you can do both the insertion and deletion, but in queue there are two sides. One is called the front end and the other is called the rear end. Deletions occur from the front side, okay, and insertion occur at the rear side, from the rear side. Okay, these operations occur at the front side, front deletion, and the rear side insertion occur at the rear side. Okay, so these two are the sides of queue. Okay, before insertion you have to check the overflow condition. What is overflow? When you want to insert an element into a queue and there is no space available to insert a new element, this condition is called overflow condition. And underflow condition, when you want to delete element one by one and there is no element left in the queue to be deleted, so this condition is called underflow condition. So before insertion you have to check the overflow, and before deletion operations you have to check the underflow conditions. Okay, the queue works on first in first out mechanism or last in last out mechanism. The element that is inserted into the queue will be served first. The priority of the first element that is inserted is high as compared to other elements. Our last in last out mechanism, the elements that is inserted at the end have lower priorities as compared to the other elements, or this element will be served at the last. Okay, so the queue works on these mechanisms, FIFO or LILO mechanism. Daily life example, when you want to deposit your university slip or any other deposit in a bank and there are multiple persons, so the person that come first will be served first. Okay, so this is the best example of queue. Okay, and from computer example, whenever the FIFO operation is there, you can implement this by using queue. So FIFO scheduling mechanism or FIFO algorithm, scheduling algorithm, you can assign priorities to multiple tasks by using FIFO. Okay, so there you can use the queue. For solving collision, this is called the arbitration rules. When there are when more than one processes have the same priorities, you can solve that collision by using the FIFO. or the queue. Okay, so the process that comes earlier will be served first. Okay, this was the brief introduction of the queue. Now let's move to the two operations. One is called the insertion and the other one is called a deletion operation. So the queue insertion procedure, this is called the push operation. Queue is the stands for the queue. Front is the front side and the rear is the rear side. X is the element that we want to insert, and N is the size of the queue. Okay, so you cannot change the size of the queue during program execution, therefore this is called the static data structure. So before insertion we have to check the overflow condition. If the rear side is greater than or equal to N, it means that the queue is full and return the control. Okay, else if the rear is not greater than or equal to the size of the queue, it means that there is space available in the queue, so you have to increment the rear by 1 and assign the X value to that location, to that rear location. Okay, so before insertion you have to check the overflow. If there is no overflow, then you have to insert the element at the rear end. And now checking for front for deletion, this is whenever the first element is inserted, it means that if front is equal to 0, there was no element in the data structure, the queue data structure. When you insert a new element for the first time, you insert an element into the queue, it means that now the front should be 1. Okay, front was 0, means there was no element. Now the front location moves to the 1, it means now there is a single element available in the queue, and if you want to delete it, so you can delete it from this end. Therefore if front is equal to 0, you have to assign 1 to the front. Okay, means now first element, there are elements in the queue data structure. Okay, so this is the insertion procedure. Now let's move to the deletion operation or deletion procedure. Pop is the name of the procedure or algorithm. Q stands for the queue. This is the front end, rear is the rear end, and N is the size of the array. If front is equal to 0, means there is no element in the queue data structures. It means that the queue is empty, or this is called the underflow condition. If this condition is not satisfied, it means that elements are there in the queue, so you have to delete the element that is at the front position. Okay, and now increment the front by 1. When you delete the first element, okay, the first element, now let's move the front to the next element up to so on. Okay, so this is the deletion procedure. This is the underflow condition, and this is the deletion procedure. Now if front is greater than rear, it means that when you delete the last element, okay, and you increment the front, it means that the front goes to n plus 1. Okay, the front goes to n plus 1 from here when you delete it. Now if front is greater than rear, means that you have deleted all the elements. Now assign 0 to both the rear at the front position. It means that now the whole queue is empty. Okay, so this is the deletion operations. Now let's move to the actual implementation. These are the header file, this is the main clear screen. You assign front with the -1 is assigned to the front end as well as to the rear end. It means that there is no elements in the queue. this is the options. You have to choose that whether you want to do insertion operation or deletion operation. I is just a variable. You will be used inside a loop. And this is the queue of size 5 having 5 element. This is the value that you want to insert. While option is not equal to 0 means that 0 is used for exit. Okay, so when you press 0 from the keyboard, this loop will be terminated. Okay, the control will goes outside this loop. So while option is not equal to 0, you can enter 1 for push operation, 2 for pop operation, 3 for printing the queue values, and from here, and 0 for the exit, and from here you can assign or enter the value to the option. Okay, so for the first time, option will have a garbage value, so that garbage value may not be equal to 0. Okay, so the control will goes inside this while loop, and here inside this while loop a switch statement is used. Okay, when you insert an option, say for example the push the 1, 2 or 3 or any other value. Okay, so the control will goes to that specific case. When you say for example when you enter 1 from the keyboard, the control will goes to the first case. If you enter the 2 from keyboard, the control will goes to the next case up to so on. So 1 is used for push operation, 2 is for pop, and 3 is for printing value. So this is the push operation or insertion. Okay, so if rear is greater than or equal to 4, why 4? Because there are 5 elements, and we are implementing the queue by using array data structure. Okay, so there are 5 elements, while in C++ the array starts from 0. Okay, so 0 to 4 there are 5 elements. Therefore we can use if rear is greater than or equal to 4, it means that the queue is full, or this is the overflow condition, and break this. Okay, else if there is space available in the queue, you have to enter value to push. You can insert that value from the keyboard. Rear side will be incremented, and you can assign that value to that specific location. If front is equal to -1, you can assign 0 to the front. It means that when for the first time you insert a value, so it means that now a value is there in the queue, and if you want to delete that value, you have to delete. So the front, when you insert first element into the queue, so the front end will be assigned to 0. Okay, from at the start front value was -1, but when the first element is inserted, now the front values will change from -1 to 0. Okay, it means that now you can delete the first element if you want. Okay, now goes to the second case. In second case, this is for the deletion. If front is equal to -1, it means there is no element in the data structure, in the queue data structures, or the underflow condition, so it means queue is empty, and break this. Okay, else assign null to the front location and increment the front by 1. In insertion, you have to increment the rear end by 1, while in deletion you have to increment the front end by 1. Okay, so you have to move to the next person or next value to 0. Okay, if front is greater than the rear end, it means there you have deleted all the elements. Now assign -1 to the rear end as well as to the front end. Okay, the third case was used for the display. If front is equal to -1, it means that there is no value for display. Okay, and else if the queue is not empty, it means if the values exist, so it means current values in the queue, use a single for loop and see out queue of I. Okay, so this will display all the elements in the queue and break this case. The default case, this is break, means the control will go from the switch statement to the while, to the body of the while. Okay, so this is used for the end of the switch, end of the while, and end of the program. Get ch means get character. Okay, so this is the actual implementation of the queue. Now let's move to the execution of this implementation. Okay, now let's move to the implementation of this queue. Okay, file, open, and go to the bin folder and queue, queue. Okay, queue data structure. This is the code that we have already seen yet. Okay, these are the header file, mains, clear screen, front, while loop, option, switch, case 1. This is for the insertion, case 2 for the deletion, case 3 for the for the printing of values, and this is the default case. Okay, so in printing I use this from 0 to the rear. You are assigning values to the rear end, so this loop will goes to the rear. Okay, so now let's execute this. Control F9. Okay, 1 per push, 2 per pop, and 3 per printing queue values. So I insert 3, there is no value to display. Now I want to insert values. Okay, enter value to push 12, now enter value to push 13. Now I want to display the values, so I enter 3 from the keyboard. There are only 2 values, 2 and 3. Now enter another value. Okay, 14, enter another value, 15, enter another value, 16. Okay, now let's print the values 12, 13, 14, 15 and 16. Okay, now I want to insert another value. Okay, this says that the queue is full, it means overflow condition. Overflow condition satisfies. Okay, now I want to delete element, so I delete the element. Now I want to check it, so 0, 13, 14, 15 and 16. This is not 0, this is null value. Okay, now I want to delete another element, delete another element, 3 elements, 4 elements deleted, 5 elements deleted. Now I want to delete another element. Okay, so queue is empty. So overflow and underflow conditions both are okay. Now I want to exit from this, so I will enter 0, but before 0 I want to check another value. Say for example I want to enter 8, so the control will goes to the default case, and default case I had just written a break statement. Okay, so again this will be displayed at enter 1 for push, 2 for pop, 3 for printing queue value, and 0 for exit. Okay, so this program will executed until this program will be terminated until and unless I press 0 from the keyboard. Okay, when I press 0 from the keyboard and press enter, now the control goes to the get ch statement. Okay, when I press any key from the keyboard, so the control will goes outside of the main function. So I click a key from the keyboard, and now let's see that the control goes to here. Okay, so this is the queue. Hope you people understand the whole lecture. Okay, and in another class we will discuss the types of the queue, that what are the types of the queue, dequeue, circular queue, and we will explain any one of them in detail. Okay, Allah Hafiz.